Hi everybody. In this video, I want to show you how we can derive and use the Newton-Raphson method for finding the roots of an equation. And we'll begin with this diagram. We've got the function of x here in this red curve. And at a point on the curve, let's say point x1, we've got a tangent to the curve. And this tangent intersects the x-axis at another point I'm calling x2. And if we want to find the gradient of this tangent, this would be m. We'll have the change in y divided by the change in x. You can see the change in y is from this point, which we'll call y1. So from this point down to the x-axis. So the change in y will be y1 minus 0 over the change in x, x1 minus x2. And if we let this change in x become very, very small, then the gradient becomes f prime of x1. And the y1 value becomes f of x1. So when you substitute this value of x into the function, we get the value of y, f of x1. So this will be f of x1 over x1 minus x2. If we look at what we're trying to derive here, we're trying to make x2 the subject. This would be the x2, this would be the x1. So we'll multiply both sides by this denominator. We get f prime of x1 multiplied by x1 minus x2 will equal f of x1. Now we'll divide both sides by the f prime of x1. So x1 minus x2 will be f of x1 over f prime of x1. And then we'll move the x2 to the right-hand side and this fraction over to the left-hand side. So x1 minus f of x1 over f prime of x1 will equal x2. And that's what we have here. We've got the next term will equal the current term minus f of x over f prime of x. Okay? In the next example, we're going to look at how we can apply this to find the roots of an equation. So we've been given this equation, and we've been told there's a root within the range of x equals 1 to 2, and we need to find that root using the Newton-Raphson method. So the first thing we need to do is we need to work out f prime of x. We need to differentiate this with respect to x. So if f of x is x cubed minus 2x minus 1, f prime of x will be 3x squared minus 2. And for our starting value of x, I'm going to choose x1 equals the start of our range equals 1. And we can work out x2 on our calculators. So x2 will be the current x value, which is 1, minus f of 1 divided by f prime of 1. And this will give us x2 equals 3. To work out the next iteration, x3, all we need to do is to replace the 1 in the calculator with our previous answer. And we get x3 equals 2.2. For x4, we'll execute this again. And we get 1.7808. And x5 will be 1.6363. x6, 1.6183. And x7, 1.6180. So to 2 decimal places, you can see that x is equal to 1.62. Okay? Let's try one more question. So do you want to read through this question yourself and try and find the root to this equation to 2 decimal places using the Newton-Raphson method? You can pause the video and come back when you're ready. So welcome back if you had a go. We know f of x is cos 2x plus x over 2 minus 1. We'll find f prime of x. When you differentiate cos 2x, we get negative 2 sine 2x. When you differentiate x over 2, we get a half, and a negative 1 will go. So if we begin with letting x1 equal the 2, the start of our range, the first iteration, x2, will be x1 minus f of x1 over f prime of x1. And this works out to be 2.3246. So x3, now we'll substitute in x2, and we get 2.2849. So x4, we can use our calculator now. We'll press execute, and we get 2.2848. So you can see, to 2 decimal places, we get the 0.28. So x is approximately 2.28 to 2 dp. Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, you can download the worksheet and view the online lesson from my website, mrmathematics.com. I'll leave a link in the description below.